Welcome to section 3.5, graph using slope-intercept form. Now I know you've used slope-intercept form before because that's the form of a line that says y equals mx plus b. And what does that mean? Well, m, that's your slope, which is exactly what you're solving for last section. Your b is your y-intercept, which is asking if you have a graph, where does it intersect that y-axis? So your y-intercept could be like right here, or it could be down right here, or it could even be at 0, 0. But that's one way to just help identify a point on your line that will be really helpful to know. And that's slope-intercept form. Y equals your slope times x plus your y-intercept. Well, this is helpful because we can go and look at equations now, and we can easily identify what's the slope and what's the y-intercept. So in this case, our slope is 3 because it's the part that's multiplied by x, and then the 4, that y-intercept, is going to be your b. This next one's in standard form. It's not actually in slope-intercept form. So to figure it out, we need to rewrite the equation and try to solve for y. So what we need to do in this case is subtract 3x from both sides, which will leave us with a y equals negative 3x plus 2. And actually, I don't want to lose you by accident, so if you didn't understand that part, we could write this as a 2 minus 3x, but we're always looking for having our number of x's first, because it's y equals mx plus b. So what we'd actually want to do is change this minus to a plus negative, and now we can rearrange the order so that we would have a negative 3x plus 2. Well, now in this case, we can see that our slope is that negative 3, because that's the part that's multiplied by the x, and our y-intercept is 2. Now let's try graphing something in slope-intercept form. Oh, shoot, it was almost the same equation. So just like last time, we need to get y by itself, so we can subtract that 2x from both sides, or add a negative 2x. So that now we'll have a y equals negative 2x plus 3. And now we can graph it. So we have our y-intercept, or where does it cross the y-axis, which is going to be at y equals 3. And then our slope is negative 2. Or in other words, our slope says we go down 2 points in y. So we'd go down 1, 2. And negative 2 is the same as a negative 2 divided by 1. So when we go down 2, we're still going to go right 1. So if you ever just have a whole number there, remember you need to put it over 1 so that you remember to actually go down instead of making it an accidental vertical line. So go down 2, right 1, and then you can go down 2, right 1, and you'll get another point. But really all you need is those first 2 points in order to make a line. But now you can graph your line and it'll work. The other option, if you like going to the left, is this negative 2 over 1. You could also think of that as a 2 over negative 1, which would then tell you would go up 2 and left 1. But whenever possible, I will always go down and right, or up and right. But my main thing is I like going to the right, because then I don't get confused about the negatives as much. So do whatever's easiest for you. That's just what I generally do. Ooh, okay, so you're in a mall, and you have an option of taking the stairs that are right there, or the escalator right next to them. Well, if you go down the stairs, you will descend those stairs on average at about 1.75 feet per second. If you just ride the escalator, you'll generally descend at about 2 feet per second. So you're going slightly faster using the escalator. If in this mall you're going down 28 feet, how much faster is the escalator? Well, there's a couple ways you can think about this one. The main thing is you just have to recognize, oh, we have to go down some distance, and that's going to equal our speed, or our rate, times our time, which distance equals rate times time. That's that distance formula we've used before. So in this case, we need to descend 28 feet, And our rate with taking the stairs is a negative 1.75 because we're going down, so it's a negative slope, feet per second. And with the escalator, it's going to be 28 equals negative 2t. Well, now we can, on both of them, we can divide by negative 1.75 or by negative 2. And t will equal negative 14 on this one, and t will equal negative 16 on this one. Now, because you're descending, that's why you had a negative speed. The time isn't actually negative. It is essentially just saying from 0, it's taken you 14 seconds to get there. So even though it's negative, in this case, we actually end up just ignoring the negative because it's a negative because we were descending, and so we've made it negative feet because of our distance. Oh, actually, better way. Instead of thinking of it as positive 28 feet, because I mean we were going up 28, let's just say, no, we need to go a total distance of negative 28 feet down. Now when we divide by that negative, we'll come out with a positive answer for t. That's probably a better way to think about it. And now since our time is positive, it makes sense. The difference between taking the escalator and the stairs is going to be a difference of 2 seconds. So if you are shopping on Black Friday and by golly, you want to make it there just slightly faster, take the escalator. Moral of the story. Now, parallel lines. In order for lines to be parallel, that means they have to have the same slope, because then they will go up or down at the same rate, which means that they won't ever intersect. So in order to figure out that lines are parallel, you could eyeball it and think you see that they're parallel, but if you're just doing a rough sketch, like clearly like my artistic abilities allow me to do, that's not always going to be the easiest thing to tell if they're actually parallel or not. So you'll need to figure out what their slopes are. So for this blue line, to get from our first point to the second point, we go up 1 and right 1, 2, 3. So up 1, right 3. For this red one, we go up 2, right 1, 2, 3, 4, 5. So up 2, right 5. Those slopes are not parallel, so the blue line and the red line are not going to be parallel because the slopes aren't the same. But let's try the yellow line. For the yellow line, we go up 2, right 1, 2, 3, 4, 5, 6. So up 2 over 6. And when we simplify that out, that's going to come down to 1/3. Well, now these two have the same slope, therefore they are parallel lines. And for anyone who was bugging, this is actually supposed to be a negative 2 down here for our x. But that's it. Now you've got your parallel lines there. You figured out which ones are parallel. And that's the final question for this section. So hopefully that made sense. And if you have any questions, shoot me an email. Otherwise, good luck.